So now let's talk about area under a curve. Let's assume we have in a Cartesian plane x, y, a curve like this, where y is equal to f of x. And then let's assume that this is x equals a, and this point is x equals b. What is the area under this curve? The area under that curve is giving us area equals integral of x equals a to x equals b of f of x dx. So this is the area under this curve. What if in the Cartesian plane the curve that was given are two curves? Maybe for example these two curves, where we have y equals f of x and then y equals g of x. What is the area between these two curves, assuming that it starts at x equals a to x equals b? The area a that is bound by those two curves is equal to integral of a to b of the top curve, which is the upper one, this one, f of x minus g of x dx. So always you subtract the top one from the bottom one. What if the curve was in this form and we're asked to find the area that is bound by this curve? And let's assume that this portion was m and then the upper limit was n. So this is y equals n and then y equals m. Then the area that is bound by this curve, where this is x equals f of y, and then this one, this curve is x equals g of y. Then the area is equal to integral of the lower limit m to n. Then the outer curve, which is g of y, minus the inner curve, which is f of y, then dy. So these are the various techniques of finding the area that is bound by either a single curve or by multiple curves. Calculate the region bounded by the curves x equals 1 minus y squared and x equals y squared minus 1. So the first thing we need to do is to find the points of intersection between both curves. So the first curve is x equals 1 minus y squared, and then the second one is x equals y squared minus 1. So let's equate the two. So this implies that 1 minus y squared is equal to y squared minus 1. So let's add 1 to both sides of the equation. So 1 plus 1, then plus 1, so that at the end of the day minus 1 plus 1 can cancel out, and therefore y squared is equal to 1 plus 1 is 2, so 2 minus y squared. So let's subtract minus y squared from both sides. So minus y squared plus y squared, then minus y squared. So this becomes, this portion goes to 0. Minus y squared minus y squared equals minus 2y squared. So this becomes 2 minus 2y squared equals 0. So let's divide through by 2. So if you divide this by 2 and this by 2 and this side 2 by 2, at the end of the day it becomes 1 minus y squared is equal to 0. So we see that this is difference of two squares. because 1 can be written as 1 squared. So let me write it. 1 squared minus y squared is equal to 0. So we can factorize it as difference of 2 squares. So this becomes 1 minus y in one bracket and 1 plus y in another bracket equals 0. So the values of y are y equals minus 1 or y equals 1. Now the next thing we need to do is to sketch these two curves. But we are having, the first one is 1 minus y squared and the second one is y squared minus 1. So let's start with the second part, which is x equals y squared minus 1. The curve of x equals to y squared looks like this. This is the curve x equals y squared. So x equals y squared minus 1. It means that the graph has been shifted to this side, the left side. So let's assume minus 1 is here. It means that instead of starting from 0, we should shift it to this point, which is x equals minus 1. The graph has been shifted to the left side by minus 1. So let's draw. So this is the curve that we want to originally draw. And remember that our limits are from, let's assume here is minus 1. And let's assume that this part is positive 1. And then let's also assume this is negative 1. And this portion 2 is positive 1. So this is our x-axis and this is our y-axis. So we are going to shift this curve to this part of x-axis. It has been shifted minus 1. So let's also shift it to the left by 1. So if we shift it to the left by 1, remember that the limit is minus 1 and 1. It means that the curve must pass through this point. So therefore, it will look like this. So this is our curve x equals y squared minus 1. And then now, let's come to this, which is x equals 1 minus y squared. Now, the curve, this graph is the graph x equals minus y squared. So this is the graph of x equals minus y squared. However, it has been shifted to the positive x-axis by 1 unit. That means we stand on 1 unit on the positive x-axis and draw this kind of shape. But the limits are minus 1 and 1. That means the graph must pass through minus 1 and 1. So this graph is going to look like this. And this is the graph x equals y squared minus 1. So at the end of the day, the region of interest that we are looking for, which is the area that is bounded by those two curves, is this area. And therefore, area is equal to integral of the lower limit, which is minus 1, and the upper limit 1 of the graph which is on the right side, the curve on the right side minus the curve on the left side. So this is the curve on the right side. So I made a mistake. This is x equals 1 minus y squared. The area equals the curve on the right side minus the curve on the left side. So this is the right side curve, which is this one, and that is into bracket 1 minus y squared, then minus the curve on the left side, which is into bracket y squared minus 1 dy, because we are integrating from minus 1 to 1 on the y-axis. So area A is equal to integral of minus 1 to 1 of. Now let's remove this bracket. If you remove the bracket, it becomes 1 minus y squared minus y squared plus 1 dy. So area A equal to integral of minus 1 to 1 of 1 plus 1 is 2 minus y squared becomes minus 2y squared dy. So let's go ahead and then do the integration. If you integrate 2, you will get 2y. And if you integrate minus 2y squared, it's equal to minus 2 over 3 y exponent 3. And all of this is evaluated at minus 1 to 1. So let's then substitute the limits and find the area. So A is equal to, let's put in the upper limit, that is 2 times 1 minus 2 over 3 times 1 cubed. Then minus into bracket 2 times minus 1 minus 2 over 3 times minus 1 cubed. So the area A equals 2 times 1 is 2 minus 1 cubed is 1 times 2 over 3 becomes 2 over 3. Then minus 2 times minus 1 is minus 2. Minus 1 cubed is minus 1 times minus 2 over 3 becomes plus 2 over 3. So A equals, let's remove this bracket. So that is 2 minus 2 over 3. Then if you remove this, minus 1 times minus 2 becomes plus 2. Minus 1 times 2 over 3 becomes minus 2 over 3. So the area A is equal to 2 plus 2 is 4 minus 2 over 3 minus 2 over 3 becomes minus 4 over 3. And then 4 minus 4 over 3 is equal to 8 over 3 squared units. Sketch the curve y equals x minus into bracket x minus 1 and into bracket x minus 4. And then the B part, calculate the area of the finite region bounded by the curve and the line y plus 3x minus 4 equals 0. So let's find the y-intercept. And for the y-intercept, x is equal to 0. So in putting 0 inside, y of 0 equals into bracket 0 minus 1 times 0 minus 4. So 0 minus 1 is minus 4, and 0 minus 4 is minus 4. Minus 1 times minus 4 is equal to 4. So we have the point 0, 4. We have the point 0, 4 as the y-intercept. Then let's also find the x-intercept. For the x-intercept, y is equal to 0. So we have x minus 1 times x minus 4 equals 0. So the values of x are x is equal to 1 or x is equal to 4. And therefore we have the point 1, 0 and then 4, 0 as the x-intercept. The next thing we will do is to expand. Let's expand the bracket. So y is equal to into bracket x minus 1 times x minus 4. So let's distribute x times x minus 4 minus 1 times all of this bracket, which is x minus 4. So this is equal to x times x is x squared. X times minus 4 is minus 4x. Minus 1 times x is minus x. Minus 1 times minus 4 is plus 4. So y is equal to x squared. Minus 4x minus x is minus 5x plus 4. So we see that this curve is of the form y equals ax squared plus bx plus c. So we need to find the minimum point, but then we need to first find the x value for which the minimum point occurs. So x is equal to, okay, so let me cancel this. So let's find the minimum value, but first let's find y prime of x is equal to 2x minus 5. So the minimum value occurs at the value for which y prime of x is equal to 0. And this implies that 2x minus 5 is equal to 0. And x is equal to 5 over 2, which is equal to 2.5. So let's find y of 2.5. It's equal to, in one bracket, 2.5 minus 1 times 2.5 minus 4. So 2.5 minus 1 is 1.5 times 2.5 minus 4 is minus 1.5. So minus 1.5 times minus 1.5. This is equal to minus 2.25. And therefore the point, we also have the point 2.5 and then minus 2.25. So let's go ahead and then sketch the curve. So this is our x-axis and this is our y-axis. So we have 1, 2, 3, and then 4. So let's assume this portion is 0 and this is 2, and let's assume this is 4. And then here's minus 2 and then minus 4. So let's go ahead and plot the points. We have the point 0, 4. So 0, 4 is here. And we also have the point 1, 0. 1, 0 is here. And then 4, 0 is this place. Then we also have the point 2.5. 2.5 is somewhere here. And minus 2.25 is a little bit below minus 2. So it's somewhere here. So we have this point. So let's then go ahead and then join the point and look at the nature of the graph. So the graph is going to look like this. So this is the nature of the graph. So the graph, this graph is y equals into bracket x minus 1 times x minus 4. But we are also giving another information, which is the line y plus 3x minus 4 equals 0. So let's sketch this line too on this same graph. So let's make y the subject. So in this case, y equals minus 3x plus 4. This is a graph of gradient m equals minus 3 and then intercept, y-intercept, y is equal to 4. So since the gradient is minus 3, that means the curve is going to look like this. However, we know that there is an intercept 0, 4. The y-intercept is 0, 4. Then let's find the x-intercept by putting y equals 0. So y equals 0 implies that minus 3x plus 4 is equal to 0. So 3x is equal to 4. X is equal to 4 divided by 3, which is equal to 1.3. So at about, so we have this point 1.3 and 0. and we also have 0 and 4, which makes up this line. So let's plot it. This is 0 and 4, and then 1.3 and 0. This is 1.3. It is a little bit above 1. So this is, so the curve, the straight line is going to look like this. So this is how the curve is going to look like. So this is the region of space that we are going to calculate the area for. But in order to find that region of space, we need to first find the point of intersection of both the curve and then the line. So at the end of the day, this is y equals minus 3x plus 4. So the area is equal to, the graph on top is integral from a to b of this graph, which is minus 3x plus 4 minus the curve, and then the curve is x minus 1 times x minus 4, all of this dx. So the task we are going to do is to find the values for a and b. The values of a and b is the point of intersection between the two graphs, and then insert the values here and find the area under this curve. So the two curves has given us, the first one is x squared minus 5x plus 4, and then the straight line is y equals minus 3x plus 4. So let's equate the two. So minus 3x plus 4 is equal to x squared minus 5x plus 4. So plus 4 and plus 4 can cancel. So let's bring minus 3x to the right hand side. So it becomes x squared minus 5x, then plus 3x is equal to 0. X squared minus 5x plus 3x is minus 2x is equal to 0. So we can factorize 2x out. So x into bracket x minus 2 is equal to 0. Therefore, the values of x are x is equal to 0 and x is equal to 2. So the area becomes a equals integral from 0 to 2 of, so originally we wrote area as area equals a to b of the straight line, which is 3x minus 3x plus 4 minus x minus 1 then x minus 4 dx. But now we know the limit as 0 and 2. So area equals integral from 0 to 2 minus 3x plus 4, then minus, we know that this product is equal to x squared minus 5x plus 4. Let me put the bracket dx. So area A equals integral of 0 to 2. Let's expand all of this. This is minus 3x plus 4 minus x squared plus minus 1 times minus 5x becomes plus 5x. And minus 1 times 4 is minus 4 dx. So that minus 4 and plus 4 can cancel out. Minus 3x plus 5x becomes 2x. So area is equal to integral of 0 to 2 into bracket minus 3x plus 5x is 2x, then minus x squared dx. So area is equal to integral of, so let's go ahead and then do the integral. The integral is equal to 2 divided by 2x squared if you integrate 2x, then minus, if you integrate x squared, you get minus 1 over 3 x exponent 3 evaluated at 0 and then 2. So this is equal to, area is equal to 2 over 2 is x, so x squared minus 1 over 3 x exponent 3 evaluated at 0 and 2. So a is equal to 2 exponent 2 minus 1 over 3 times 2 exponent 3, then minus into bracket 0 squared minus 1 over 3 times 0 exponent 3. So this part, everything becomes 0. So the area is equal to 2 exponent 2 is 4 minus 2 exponent 3 is 8, so 8 over 3, then minus 0. So 3 times 4 is 12. 12 minus 8 is 4. So area is equal to 4 over 3. And this is equal to 1.33 squared units.